8.1 integral is a net change. So we've been working with integrals and you guys are getting a little bit better with evaluating them. At this point, we're going to look at the uses and apply the integrals to word problems. So we had talked about this before, the idea of net accumulation. Example 1 here, a car travels at a constant velocity of 60 miles per hour. It's just on cruise control here, along a straight road, no curves, no bends, for 2 hours. So after 2 hours, how far has the car traveled? So we have 60 miles per hour. This is just a basic unit problem times 2 hours. That gives us 120 miles per hour. Not miles per hour, sorry about that. It'd just be miles, right? Because the hours would cancel out. Miles. All right, so that is the easy part. Graph the car's velocity against time. Here we go. We have a velocity versus time. We have miles per hour and hours. So we're talking about 2 hours, and the velocity is 60. How does your answer manifest itself with respect to the graph? So in order to multiply miles per hour times hour to get that number, we're talking about area under the curve. So we have 60 miles per hour times 2 hours would give us 120 miles. So the answer manifests itself as the area under the curve, or the integral from 0 to 2 of the velocity function. Okay, so we're going to be looking at those kinds of things. This one's a little more interesting. Now the velocity is given by this function. So we're going to sketch it first. So we have velocity, we have time, and this is in hours, this is in miles per hour again. It's not necessarily going to be drawn to scale, but I do know that at 0, it would be at -4. At 2, it's going to be crossing, and at 5, it's going to be pretty fast, pretty high up there. Okay, so now we have this. I have the velocity function. During which times is the car traveling in the negative direction? Well, that would be any time the velocity is negative. So the car is traveling, and you should write this out. The car is traveling in the negative direction on the interval from 0 to 2. Okay, it's traveling in the positive direction whenever the velocity is positive, which would be 2 to 5. What time does the car change directions? The car changes directions right at that second when the velocity is 0, or when t equals 2. And now we're going to evaluate each of these things. 0 to 2 of the velocity function, the integral. Okay, so we're looking for this here, this value. This is a function we can do by hand. I'm not going to do all of them by hand, but I just want you to see this. Add 1 to the power, divide by that new power, so we get 1/3 t cubed minus 4t. We're evaluating it from 0 to 2. We plug in 2, we get 8/3 minus 8, okay, then minus 0. So we're going to end up with what, negative? So we have 8/3 minus 24/3 negative 16/3. Nope. Yep, okay, I do know what I'm doing. There we go, negative 16/3, and this gives us miles. So that number means that it traveled negative 16/3, or if you want a decimal, negative 5.333 miles in the negative direction. This, I'm not going to do each of these by hand, like I said, but from 2 to 5 of v of t dt. If we evaluate this, this is 27 miles, and that means the car traveled 27 miles in the positive direction. if now we change to 0 to 5, if we evaluate this, we get 21 point about that miles. This gives us the car's displacement. Okay, you've probably heard that word before. It gives the car's displacement, the net change over that time. So it drove in the negative direction, then it changed and turned around and drove in the positive direction. So this gave us how far it was away from its original point. And then this last part from 0 to 2, or 2 to 0, and then 2 to 5, that would give us the total distance traveled. Okay, and that would reflect itself as the area of the graph under the curve. Okay, the area. So that gives us the total distance here in miles, of course. All of these are in miles. And then our last point, suppose the car started 4 miles away from the checkpoint on the positive side. Where's the car in relation to the checkpoint at t equals 5? Well, since it went overall 21.666 miles over that distance, okay, because it started at 4, went backwards some, and then it came back towards that positive direction. So we're just going to add 4 to that. So it would be 25.666 miles away from the original checkpoint. All right, continuing. These are just summaries. This is what I was just talking about, displacement. It's your net change in position. When you do an integral, it takes into account the negative and the positive, and that gives you your displacement. Your distance traveled is a little bit different. That is the absolute value of absolute value of velocity, which is the same as speed. That gives you the total distance traveled, whether it's backwards or forwards. And then position, a position at any time is where you started plus where you went. Okay, so we're going to look at that kind of problem next. This is one of the actual AP exam problems, and the mean value on this was 4.67, so that was pretty good. I probably won't get through all of this in the video, but I want to talk about a few of these. So let's look at part A. Find the acceleration. You can read this, okay, go for it. Find the acceleration of Karen's bicycle at time t equals 5 minutes. So we're trying to find this. We are only given a velocity graph, okay? That's important to note what kind of graph this is. So that means we're trying to find v prime of 7.5, which in this case you can just determine by a slope. What is the slope right here? So we're going to do v of 8 minus v of 7 all over 8 minus 7. That'll give us the approximation for the slope there. And if you you could put numbers, you could put 0.2 minus 0.3 over 8 minus 7, or if you want to simplify it, it's negative 0.1. And our units now, the slope of this, so it would be miles per minute, or miles per minute squared. This is the hard part that a lot of people have. Explain the meaning of something. So this integral, the absolute value, in terms of our trip, it gives us the distance traveled. So we're not taking into account whether these things are negative. Okay, like this part, that means she went backwards. We're still counting that total distance there. So find the value of that. That's something that you can do, and I'd like you to do that for your WISC. Find the areas here. So just find the area of this triangle, this triangle. You can break these up into a trapezoid, another trapezoid, and then another trapezoid, whatever you want to do. But I want you to find the value of this. And then we'll talk about how to explain the meaning. I would like you to try. Okay, what do those numbers mean? And then we'll talk about it in class. So shortly after leaving home, Karen realizes that she left her calculus homework at home and she returns to get it. When did she go back home? Well, if you look on the graph, the only time she would have traveled backwards would be here. So that tells us that for part C, and you should write it out, Karen turns around at t equals 2 minutes. You should always try to use your units if you have them. And that is because the velocity changes, and don't just write changes signs, changes specifically from positive to negative at t equals 2. All right, and last but not least, part D. So we need to find how far Karen went, how far Larry went, and who lives closer to the school. So we're talking about, we need to find Karen's displacement. Okay, so for Karen, we're going to model her displacement as 0 to 12 of v of t dt. And when you get that, you should get 1.4. All right, and then Larry, we're also going to model from 0 to 12. Okay, we called this one w of t dt. This is a calculator problem, so you can just do this right on your calculator. You could do the antiderivative of this, but don't. Don't waste your time. Okay, when you plug that in, you get 1.6. So Larry lives 1.6 miles away. Karen lives 1.4 miles away. Since 1.4 is less than 1.6, Karen lives closer to the school. Okay, and just lastly, as a recap here, I want to talk about the points of this problem. So part A, you get 1 point for writing the value. You get 1 point for writing the correct units. For part B, there are 2 points in this problem. 1 for explaining it and 1 for the actual number. Okay, so the explaining part and then the actual number. So we have 2 points for part A, 2 points for part B. Part C, just for saying what time, you get 1 point there. What time that she turns around, and then why, you get another point. So 2 points for part C. So that means D holds 3 whole points. You get 1 point just for writing this integral here. You get 1 point for getting his distance, okay, and 1 point for getting hers and explaining that she lives closer. So that gives us our 9 total points. We're going to continue practicing these free response questions. That's going to be the best way for you to prepare.